Hello, today we will use graphical rapid analysis of structures program to analyze our beam and frame examples in drawing the shear and moment diagrams. Uh, Opening the GRASS program, go to the options menu and the units. Since our examples are in English units, we have to take care of this one and go to the grid. We will be using 10 steps because it's we have a larger or longer length for the beams. For the first beam, we have 40 feet, so we can just draw 40 feet here. As you can see, it takes longer, so we will just make it smaller here. Yeah, and then the reactions, hand support and roller support at both ends, and we can add the forces involved. We have the concentrated load, which is equal to 80 kips at a distance of 10. Add, you can add another concentrated load, 40 kips per foot at a distance of 30. Okay, then you can save your work. First, I have saved this one, beam 1, or actually this is example 6.6. So beam of example 6.6. Okay. After saving it, you can run the analysis and check for the reactions. We have the same reactions with example, that's 70 kips at the left with no horizontal reaction and 50 kips on the right support. And you can just directly look at the shear diagram. Yeah, you can also put the results, show results with values so that you will get the values here. It's 70 and 50, but here you cannot easily look at it. You can just click on the member to see the details. Check for the share, and that's around 70. Then negative 10 here, and then negative 50. Aside from that, you can just look at the moment, which is also you cannot just see it here. So look at the details. You can see the maximum is 700 and the other one is 500. But there is an easy way of doing that. You can draw another beam for this particular distances. You can put the same supports, hands and roller support on the other side, and you can add the loading here, which is equal to 80, and here, which is 40. By the way, you can also add the add dimension lines if you want to make sure that this is 10 feet, this is also 20, and then this is 10. Sorry for this one, we have to add at this portion. Yeah, the total dimension of the beam is equal to 40 feet. So we can save again our work and do the analysis. So as you can see, the reactions are the same, except that we have made 2 or 3 members of the beam. Imagine if we just have to cut it this portion, there is still a bending moment because we haven't released the moment here. But if you release it, the result would be different. The other thing about it is that when you click the shear diagram, it will give you the values here at the intermediates uh, beam, because we have divided the beam into 3 segments. That's minus 10. Also for the bending moment, it will give you 700 and 500. Also, if you want the axial diagram, there is an axial force diagram here, but since we don't have any axial force, so it will not give us the value. Or here actually it's 0. Or in advance, you can just draw the deflection, and the advantage of dividing it into 3 segments is that under the load 80 you will get the displacement, so with under the load of 40. But if you want to see at the middle the maximum, then you can also divide this into another segment so that it will give you the results. That's how structural analysis programs work. Okay, next is we have to go to the other example. Of course, we have to go back to the units, English units, and then the grade system. It should be by 10 so that it would be easier for us. We can directly draw uh, 40 pit. Again, you can just look at the status at the bottom. That's 40, and then we can have 20, another 20. Yeah, because we have a distance or a length of the beam equal to 80 feet. Here we have 40 feet, 20 feet, and 20 feet. So the total length of the beam is equal to 80 feet. And of course, the supports on the left is a hand support and a roller support at point B here. This is point B. Then after that, of course, you can use the select and select members to select two members because we need to load this one with a uniformly distributed load of 4 kips. Yeah. So that's how we do it. Or you can choose the nodes using select and select nodes icon. Of course, the loading here is equal to 30 kips. I specifically divided it the beams into 3 segments because I need to add 30 kips at that portion. And also when you are looking at the result of the shear and moment diagram, it will give you the quantitative value. So you can save it now. This is beam 6.7 or example 6.7. You can analyze, perform the analysis, and it will give you the reactions, which is 116.7 and 193.33, which is the same with our example. And now we can look on the shear diagram. Here is the shear diagram. You can show the numerical values, 116.7 here, minus 43 here, and of course this is minus 43. The other point here is minus 73, and we have minus 153.3, then 40, and 40. So with the bending moment diagram, we have 0 here, but here that's around 1467. The same with our result, and then here we have minus 800. If you want to know the maximum value here, you can just select this member, look at the moment values, and you will see the maximum value here is around 1700. That's at around 30 feet. If you want, you can actually check the result. You can sum up moment or shear to determine the shear which is equal to 0, which is at this portion. Yeah. How do we determine that one? The shear here is approximately equal to 0 in between 15 and 16. That's in between 28 and 30. So it's not exactly at 30. So we can do that by looking at the reactions first. That's 116.67 minus the or divided by the 4, so that's 29.111666. Okay, yeah, so that's the distance, 29.166. If you have to use that one to directly compute the moment using an equation, we can say that is 29.1666 times 29.1666 divided by 2. That's 1701. Yeah. In our result, here approximately at around distance 30 feet, that's 1,700. But the highest value of the moment is 1,701. In our example, that's 1,702. Okay, so there is just a round of error in this particular case. And also you can just look at the deflection. As you can see, there is a deflection here, and the deflection at the overhanging portion of the beam is up, not down. Also, you can look at the other example, a more difficult example, the cantilever type. You can go back again to the units, and then the no, sorry, the grid, it should be by 10. Then we can have a smaller screen. So draw the lines that's around A from B. A to B is 100 feet, so it should be 100. It should be beyond. This is quite small. So yeah, we can change the nodal coordinates by clicking this icon. That should be 100. Or actually, you can also add numerically here. Add numerically, we have at 100, 0, then next is 190, 0. Add, and then 190 plus 30, that's 220, 0. Then 120, 200, 310, then 0. Okay, going back, I can add it numerically. That's around uh, 310, 0. No, from, that's not 310, but from 220 to 310 add, and then 310 plus 90, that's 400, 0 add, and then 100, so that's 500. So we have a 500 bit beam. So this is quite long. Anyway, uh, we can do it this way. And to check, you can have the dimensions. That's 100 feet, then 90 feet. This should be 30, and this should be 90, then 90, and then 100. Actually, the beam is symmetrical with a hand support at this portion, a roller support here, a roller support on this side, and a roller support here. The other portions, these two are there is a hands or a moment release, so we can just click this uh, member and releases, then click this member twice. Here you can click once. So here it indicates that we release the moment at one end. So now we can select all members, select members icon, select everything, and then add member loads. That is a uniformly distributed load of 2 kips per linear foot. Okay, so that's how we do it automatically. It would be easier. And also the concentrated load here, I have put another point here for easy reference. So that's 100. Then after that, we can save our work. This is example 6.8 of Nelson and McCormack. So that's 6.8. Then I can run the analysis and look for the reaction. The reaction in this case should be the same in our example. 156.5 downward, 731.5 upward, 636.5 upward, and 111.5 keeps downward. So we have the same results, and expectedly for the shear, first they should have the same result. So here we have the different forces. As you can see, the shear values are the same. Minus 156.5 here, minus 356.5 here, 375 here, then we have 192. Here we have minus positive 35, but here it's quite difficult to see. So you can just look at this table, but then that's 135. Okay, so here we also have minus 325, 311.5, and 111.1, point 0.5. Then for the moment, we can have this diagram, and you can show the values also. Here, the maximum value for the moment is 2000, no, 25,650. That's negative. And also here. But take note, at the moment release, the moment is 0. And that is logical because we have released the moment here. The maximum moment at the middle can be found by looking at this diagram for the maximum value. Here, around 5,256 at 18 feet. Yeah. You can verify that if you have time to check by calculation. Also for the moment or for the deflection, you can just see this one. It deflects at this portion because this is the cantilever type of structure. And lastly, we want to show you the frame example. Here is a very simple frame example. Again, go back to the units and then the grade. Anyway, it's not really a problem, but we will just pretend. Yeah. Then we have 10 up, then another 10 up, and another 10 and 20. Yeah. So here we have the hinge support and then a roller support, and of course the height of this one should be 20 and this is 30. Then we have the corresponding distances here, which is 10 and another 10, but here should be around 10 also. Wait, sorry for that. We can remove it, then redo. Yeah, so that's good, and we can apply the forces here. That's around 60 kips, and here also, which is equal to 70. Again, it's not necessary that you have to divide it by 4 segments. You can just add 2 members here, and it will give you the same result supposedly. Then you can save your work. Frame, I just name it frame 6.13 because this is example from 6.13, and then you can analyze, check the reactions. We have 60 horizontal, 30 up at the left support and at the right support, which is equal to 45. Then you can just show the shear diagram. Yeah, this is the same shear diagram that we have. This is for the first segment and the second segment, and for the moment you can look the moment diagram and its corresponding values. We have 0, 600, 600, 900, and 0. Okay, we have the same result. Also for the deflection, which is our ultimate goal later on, you will see, because this is a roller support, so it will move horizontally but not vertically. But for the left support, it prevents the rotation. No, it doesn't prevent the rotation but prevents the translation horizontally and vertically. Another example, the last frame that we have, this is more complicated than earlier, but again, it's quite easy to analyze it using software like the GRASS software. Okay, so we can just draw again the same beam actually. We can have, no, huh? Sorry for that. I think it's easier if I will just do it numerically. So we have 0, 0, and then 0 and 10. Add. Then 0 and 20. Add. And then 20, 20. And then, of course, 40 bit by 0. Then close. We can zoom out or zoom in this one. Let's zoom out. Yeah. Then the support here is a roller support. Hand support here is a roller. And again, if you want to check the dimensions, you can just add the dimensions. Here we have 20. This one, yeah, 20. Okay, then we can add the uniformly distributed load here, which is equal to 2 kPa per linear foot, and the lateral force here, which is equal to 20, and we have also a lateral force here, which is equal to 10. Yeah. So actually, this is really difficult in doing it manually, right? As you can see, after saving frame example 6.14, analyze, then you will see the reactions 120 horizontal, 25 downward. We will see our result if we have the same results 65. And no, we have a different result. What happened? Uh, this should be roller. No, sorry for that. It should be 10, not 100. That's why we have a different result. Okay, then saving again and performing the analysis, and the reactions is 20 vertical, 30 horizontal, 20 vertical on the right. That's correct. We have the same results, so we can now draw the shear diagram with the quantities 30, 10, which is the same, and then a triangular 20 minus 20, and this one minus 14.14. You can see here, no, this one. This should be share. Yeah, that's 14.14. Okay, for the moment, we can just draw that one. That is 300, 400. We have the same moment, and here 400. But for the maximum here, you can just click this one and look at the middle. At the middle, it's 10. The value is 500. So we have the same results as before in our example. And lastly, the displacement of the frame. As you can see, the left support is a hand support, which restricts the movement horizontally and vertically. But in the right hand side, this is a roller support, which restricts only vertical movement but not horizontal movement. So this is the elastic curve of the resulting frame, or the displacement curve of the resulting frame. Okay, so that's all for the analysis using software, and I hope you're able to grasp and appreciate more on how we analyze the structures using softwares. That's all for